Provitamin A. Vitamin A can be obtained from foods either as preformed retinol from animal sources or as provitamin A carotenoids from plant sources. Retinol is present in foods linked to a fatty acid. These so-called retinyl esters first have to be hydrolyzed by an enzyme called lipase that is secreted from the pancreas. This occurs in the upper part of the small intestine during the digestion of dietary fat. The retinol that is released is then absorbed by the intestinal cells, where it is coupled again to a fatty acid. This esterified retinol is then incorporated into chylomicrons and passes through the lymphatics into the systemic circulation. Although some of the absorbed retinol is dropped off at various target tissues, most of it is taken up by the liver, where it is stored in stellate cells. These are specific cells of the liver that contain high levels of fat. The provitamin A carotenoids can also be absorbed by the intestinal cells, although not as efficiently as retinol. In the intestinal cells, carotenoids can then be split by an enzyme to form retinal. In the case of beta-carotene, 2 molecules of retinal can be formed because it is split at the central double bond. The splitting enzyme, 15,15-didioxygenase, is controlled. The better the vitamin A supply, the lower the activity of the enzyme. The retinal molecules that are formed from the carotenoids are converted into retinol molecules. These molecules then mix with a pool of retinol that is derived from animal sources, are incorporated into the chylomicrons, and ultimately end up in the liver. Since vitamin A is not soluble in blood, it is released from the liver as retinol through bonding to the plasma retinol binding protein, RBP, which is also synthesized by the liver. Due to its small size, the RBP retinol complex would be quickly lost via excretion in the kidneys. However, coupling to transthyretin, in short TTR, which results in the formation of the RBP-TTR retinol complex, prevents such loss during renal filtration. The RBP-TTR retinol complex can bind to receptors that are on the surface of target cells. After binding to the receptor, retinol is released from the RBP-TTR retinol complex and is taken up in the cell. Retinol can then be either stored until needed or directly converted into another biologically active form of vitamin A.